Hey there, John Morris here, johnmorrisonline.com, and welcome to another episode of The John Morris Show. And in this episode, I'm going to be covering another code snippet, and in this code snippet, we're going to be talking about hashing passwords. So this is a key security skill that you'll want to definitely learn if you haven't yet, and we're going to be talking about some of the new functionality in PHP that's going to help make this a lot easier for you and a lot more secure. So if you need to learn how to hash passwords, be sure to stay tuned for the episode. This episode is sponsored by the Complete Web Developers course taught by Rob Percival on udemy.com. Now, what I love about this course is first how comprehensive it is. It's 235 lectures on HTML, CSS, JavaScript, jQuery, Bootstrap, WordPress, PHP, MySQL, APIs, and mobile apps. I mean, it's ridiculous. Second, I love how good of a teacher Rob is. As a former school teacher, Rob knows how to explain complex concepts in ways anyone can understand. And of course, the cool thing is I talked Rob into giving my audience an 85% discount on the course. So check the description of this video for a special link that contains a coupon code good for 85% off of the Complete Web Developers course by Rob Percival. Click that link and you'll be all set for the discount. Now, on to the episode. All right, so when we start talking about hashing passwords, the first thing that I want to give you is I want to give you the concept of how you do this in the context of user registration and user login. Because if you've never taken a look at this, then it's usually the first thing that's kind of confusing because it doesn't. When you hear people say you need a one-way hash, immediately the question that comes to most people's mind is, okay, so when someone logs in, then how do I make sure that that's the right password? I know years ago when I was first learning this, that was kind of the first thing that came into my head. And so it took me a little bit to get my head around exactly how it worked. So let me just cover the concept real quick. So what happens is, when someone registers, they're going to enter all of their normal information, username, name, whatever information you're collecting. And most of that you can store in the database how it is. You don't need to hash it or do anything special with it. However, when it comes to passwords, you never want to store passwords in clear text or plain text in a database. And the reason is because if someone were to hack your database and you had all the passwords stored in there in plain text, then they would suddenly have access to all of those people's passwords. And the sad reality is most of us use our passwords across multiple sites. Because you might think, well, if they hack the database, I mean, you're kind of already screwed, right? Well, most people use the same password across different sites. And so if someone gets someone's password from your site when they hacked your database, then they can probably use that or try to use that in a number of other places for that same person with that same email address and so forth. Plus, you just always want to make it harder. A password is the most sensitive thing on a lot of sites as far as data. So you want to make sure and provide as much security as you can. So the rule is you never store passwords in plain text in a database ever. All right, so in order to accomplish that, then we have to hash the passwords. And so what a hash is it essentially takes the password that the user entered. So let's just say, for example, 1234 is the password they entered. It takes that and it runs it through some sort of processing that essentially jumbles it all up. And when it gets stored in the database, it's not 1234. It's a whole long string of characters. And in general, the longer the string, then the harder it is to crack because it takes longer for some sort of machine or that was trying to crack it to do so because there's just simply more characters. So we have lots of different ways that we can do that. And we're going to that's the bulk of what we're going to cover in this lesson, but you first need to do that. Okay, so when they register, you hash their password and you store it in the database along with the rest of their user information. Now, you don't have to put it in a separate table or anything like that. You can just put it in along with everything else as long as it's hashed. Then when they log in, what you do is you take the password that they enter on login and you rehash it exactly the same way you did when you stored it. And then you pull the stored hash from the database and you compare the two. And so if you hash it exactly the same way you did when you stored it, and you pull what you saved on registration from the database, the two should be exactly the same. And so you essentially compare the two to see if they match up and are exactly the same. If they are, then you know that they entered the correct password and you can go ahead and let them log in. So that's the concept behind hashing and checking those on login. Now, in the past, there was a lot of different ways this was done and accomplished. Fortunately, with PHP 5.5, the makers of PHP have actually come out with a password hashing API that handles a lot of the hard work for us. Before, you had to generate all your own salts, and you really wanted to do salts that were different for each site that might install your script. So if you're distributing a script like, say, WordPress, when you installed it, you'd want different salts for different sites. You wouldn't want to use the same one across all sites, and so on and so on. And so it could be pretty involved. But with the new API, PHP essentially handles all of it for you. And using this new API makes it so that your scripts that you write or your applications that you write will be future-proof in a sense. Because when PHP, if there comes an update to an algorithm, the way in which something is hashed, then updating your PHP will essentially automatically have you start using that new algorithm. And so you can future-proof your script so you don't have to constantly rewrite your code to update it. You can use the built-in API in PHP 5.5. It'll kind of take care of all of it for you. It's kind of like prepared statements in protecting against SQL injection attacks. If you use prepared statements, PHP takes care of all of that for you. Here, if you use the API, PHP is going to take care of all of the hard stuff for you. All right, so let's talk about what's inside of this API. There's really 4 functions that it makes available. So you see this function here called password hash, this one called password verify, this one called password needs rehash, and this one called password get info. These are the 4 new functions that the PHP password hashing API makes available. The 2 that we're primarily concerned with are password hash and password verify. And as you might imagine, when you want to hash a password before storing it in the database, you would send it through password hash. And when someone logs in and you want to verify that they have the correct password, you would use password verify. Okay, so in order to do this, then the password hash function requires the password that the user submitted, and then it requires an algorithm. And so the algorithm is, you may have heard of MD5, you may have heard of SHA-1, 256, all these different ones, Bcrypt. There's all these different ones that are out there. What's nice about this API is it actually lets you set, so you see I'm calling a property from this class called this algorithm. All right, well, I'm setting that up here at the top, and I'm setting it to password default. And so this is, again, new to the API. And what that means is that by default, currently, PHP is going to use the Bcrypt algorithm. Now, that is considered the most secure at this current point in time. However, as we know, as computer technology advances, these algorithms can change and get more complex and so forth. And so Bcrypt, 5 years from now, may not be the most secure. It may be something else. So what PHP will do essentially is, as those algorithms update, it will change what the default is to be the most secure. So let's say PHP 5.6 comes out, and we found that there's another algorithm that is more secure than Bcrypt. Well, PHP will update the default so that it's using the new, latest, most complex, most advanced, best, most secure algorithm. So if you set password default here, you don't have to constantly change it. You don't have to constantly keep up with it and remember it. PHP is going to do that for you, and you just need to make sure that you keep PHP up to date on your server. And that'll ensure that you're using the latest algorithm. So the recommended setting here is password default as the algorithm. Now, of course, you can override that if you happen to be a security expert and sitting here listening to me thinking I'm an idiot and you need to use some other algorithm and so forth, then by all means you can do that. You just pass it in here yourself. Okay, so you put in the password, you put in the algorithm, and then the last thing is a set of options that you can set. So the two main ones here are a salt and a cost. And so the salt is something that was used, as I mentioned before, you had to create a salt, which was a long string of characters that was then used as a part of the hashing algorithm to help jumble up all of the password characters. With this new API, if you don't set a salt, PHP will go ahead and create one for you. And that, again, is the recommended method of doing this, is to let PHP create the salt for you. So most of the time in this options, this is an array. This takes an array. And so, for example, for the salt, you would just do in the array, you'd put salt and then whatever you want the salt to be. For cost, you'd put cost wherever you want the cost to be. Now, again, if you don't add that element to that array for the options here, then PHP will create the salt for you. That's the recommended method of doing this. The other one is the cost. So it's the computational cost. So when someone's trying to brute force a password and they're trying to crack it, what part of how you stop that or how you slow it down to make it not feasible is you make the computational cost higher, because then each time the cracking machine tries to process and crack the password, it costs more time for each computation or each round that it goes through. And so if the computation or the cost of the computation is higher, that means it's going to take longer for that machine to crack that password. And so the idea is to make it not feasible to where it would take 20 years or 30 years for a computer to crack a password. And that becomes not feasible to a hacker, because in that 20 years, so much is going to change that having that password cracked will probably be useless 20 years from now. So that's the whole idea here. So the computational cost is you telling it how much it should cost in order to run the computation. Now, the flip side of that is the more computational cost, the higher it is, the slower it's going to be when you're actually hashing this password for your users. So you have to find a balance between making it hard for hackers to hack, but also making it so it doesn't take so long that your users hate using your site, or it's so slow that it becomes unusable for your users. So it's a fine balance here. And I'm going to talk a little bit later about how you can figure out that balance and what PHP recommends for that. But the default cost here is set to a value of 10. Now, exactly how that value of 10 is used and what it means, I don't think really matters. But the higher the number, the more the computational cost. So the default is set to 10. Now you'll see here, I'm again using a property from this class called options. It's set empty here. I create an array here, but the array is actually empty. So in this class, I'm using the defaults in PHP, the default salt, or the salt that it creates automatically, and then also the default cost of 10. Again, we'll talk a little bit how to figure out a cost for your particular server, although 10 is probably going to be pretty close for most servers. All right, so that's password hash. So this function will hash the password and return the hashed password to you. Okay, and we'll talk a little bit, and again, a little bit about what we're going to do with that. But the idea is you get that back from PHP. from this function, and then you store it in your database along with all of your other user information. Okay. Next is verify. So verify is really pretty straightforward. It's when someone logs in, you grab the password that they submitted, and then you grab the password that you have, the hash that you have stored in the database, and you pass both of those to this verify function, this password verify function, and it's going to check, it's going to hash the password for you and check it against the hash that you have stored in the database and tell you whether or not they're a match. So it's going to do all of the hard work for you. And you need this because up here, PHP hashes it for you. It uses a salt that it determines. It uses a method, an algorithm that it determines. So you don't know any of that stuff. So you have to pass it to password verify when you use password hash, because that's what's going to know what algorithm was used, what the salt was used, and so forth. Now, again, I'll show you a little bit. You can actually see that somewhat in what gets stored in the database. But again, it's best to just let PHP handle this. So this is what you would want to call on login when you want to check to see if the password that someone entered is correct. And again, you'd take their password they entered, you'd have what you have stored in the database, and you'd pass those into this function, and it's going to return true or false. True if it's the correct password, and false if not. All right. Next is this password needs rehash function. So what this essentially says is it's going to check if the current password that someone submitted, if it needs rehash, or the current hash that someone has, if it needs rehashed. So this is this pertains particularly to when you update an algorithm, for example. So let's say we're on Bcrypt now, and 5 years from now it's some other algorithm. Well, and you still have the same site, and you have a bunch of passwords stored in your database, or hashes stored in your database, that are on the Bcrypt algorithm, and now you're using some different algorithm. Well, you can actually check and see if that hash needs rehashed, and you can use this method to do this. So this method will return true or false and tell you if that hash needs rehashed. And I'll show you how to use that here in just a little bit. But that's what this function does. It also applies to options. So again, you can set your own salt, you can set your own cost. Well, if you change those, that's going to change the hash. So again, if you change options, this method then can check to see the hash that's stored in a database if it needs rehashed based off you changing these options or the algorithm changing. So that's what this does. Finally, get info does exactly what it says. You can pass in a hash, and it's going to tell you what the algorithm is, what the cost is, and what the salt is. It'll tell you any of the options that you've set. So it'll tell you the algorithm and any of the options that you set here for that hash. So you can get some info about a particular hash. All right. So those are the methods that the API adds. Now we want to talk about using them. So let me just talk about this class real quick. So you notice here in this hash method that I have in this class, all we're passing in is the password. I'm passing that to the password hash method. Then I'm using a property algorithm and a property options in this, passing those to this function instead of having to always set those when we call this method. Just making this a little bit easier. I do the same down here with needs rehash, and you'll see up here, those properties are actually set up here. So algorithm is set to password default. Options is created in the constructor, and it's actually just blank. So it's going to use the default options. All right, so that's the class. Most of these methods inside of this class are actually just really wrappers for, so hash here, for example, it just returns directly what comes from password hash, the actual PHP function. So it's not doing a ton here, but it is making it a little bit easier because we've set the algorithm and the options that we want to use. So that means if you wanted to change the algorithm for this entire class, you wouldn't have to come through here and change it. You actually would just change it up here. Or if you want to set options, you don't have to come through every method and change it. You just set the options up here. That's what essentially these methods do. They make it a little bit easier. Now, I've also added two other functions in here. So one is called hash and store, and this is emulating what you would actually do with this particular class. Now, you could debate whether these methods actually belong in this class. These might actually go somewhere else in your application. And so if you want to pull this hash and store method and this get and verified method out of this particular class and use them somewhere else, then that would definitely make sense. But I put them all in here so you can see essentially what we're going to do here. So what you would do is in your application, you would call hash and store, and you would send it the password that the user submitted. This is on registration. Okay, what it's going to do is it's going to hash the password, which is the first thing that you want to do. It's going to check if the hashing was successful. You never know, something could go wrong. So if it was not successful, we're going to turn false, and then you can handle that in your application. Then the next thing you want to do is store the password in your database. Now, I haven't written any actual code here because, one, I don't want to go down the rabbit hole of talking about storing in a database. I have plenty of other tutorials out there about how to store in a database, so you definitely want to check those out. But the idea here is once the password is hashed, then you would store it in your database along with all of your other user information. Then you want to check if storing that was successful, because again, you never know, something could happen. So check if storing that data in the database was successful, and if it wasn't, again, return false, just like we did up here. And then if we make it through all that, then we're just going to go ahead and return true, and that lets your application know that the password was hashed and stored appropriately. Now, again, you could alter this depending on your application. You may not want to return true and return false, or at the very least, you may not want to return true. You may want to actually return the hash. You may want to do something else in here, but that's the basic idea. Hash the password and then store the data inside of your database, and then let your application know that the hash and store was successful. All right, next is verify password. So this is the one that we need to do a little bit more on here. So what's going to happen is you are going to submit the password that someone sent to your script on login. So when you log in, you type in your password. You're going to take that password that they entered and you're going to pass it to this get and verify method or whatever you end up calling it. Then you're going to grab the hash that you have stored in your database for that particular user, right? So they enter their username and password. You're going to query your database for that username, and you're going to grab the password that is stored for them, or the hash that is stored for them. And so we set that here. Now, again, I'm not going down the rabbit hole of doing database stuff. You can check out my channel in my site for all of the database storing stuff, but we're just putting in this pretend hash here. Okay, so this is simulating like what you would get from your database. Then we're going to see if it's a match. So we call our verify method, which basically just calls password verify from PHP. We're passing in our password and we're passing in our hash that we just got from our database. And this is going to tell us if these two are a match, if the password that was entered was correct. If it is, then what we want to do is we want to check to see if that hash needs rehashed. So this is how you make your application so that it can easily update over time when you change options or algorithms are updated. That is, every time someone logs in, you check the hash to see if it needs rehashed because the algorithm has been updated or you've changed options. You have to do this on login because that's the only time that you have the plain text password from the user. Remember, they entered it in your login form and you right now have that plain text password. This is the only time you have it. So now is when you need to check to see if you need to rehash it. And if you do, go ahead and do that now. So we send our hash, not the password, the hash, to our needs rehash method to see if it needs rehashed. Again, because the algorithm or the options have changed. It's going to return true or false. If it returns true, then you see right here, we call hash and store right up here. We rehash that password and we rehash the plain text password and we store it over top of the old one. So essentially what this does is every time someone logs in, it's going to check and see if their password needs rehashed. And if it does, then it's going to rehash it and restore it for them with the new hash. So that makes it so that, again, 2 years from now, if PHP changes the algorithm, you don't have to actually come in here because we're using password default. You don't have to come in here and change anything. You don't have to go to your database and do anything. All that really has to happen is for you to update your PHP. And then from that point forward, when your users start logging in, it's going to automatically rehash their password for them with the new algorithm so that they're update and secure. And keep in mind, that's the only place you can do this, because you can't just go through the database and rehash passwords, because what's stored in the database is the hash, not the plain text password. And you need the plain text password. So this is how you make it very future proof and make your application as secure as you can, so that you're using the latest stuff from PHP, but you're also updating it as best you can. You can't force your users to log in. You can't go through the database and rehash their passwords for them. So you're updating it and keeping it as secure as you possibly can as things update and upgrade and so forth. All right. So that's what we're doing inside this class and inside of these different methods. The last piece here then is this method down here called find cost. And so you can read what it does right here, but essentially this code is going to benchmark your server to determine how high of a cost you can afford. So remember, it's a balance between making it hard for hackers to hack and making it so that it's not unusable for your users. So this is actually going to benchmark your server and tell you what cost you should use. So if we come over here to this hash.php, then we can look at a couple of these things. So I've required the hash password class, and I've set just a example password here, 1234567, and then QWERTY. And then I'm instantiating a new instance of the class. So this is how you would use it in your application. And then I'm hashing a password and I'm echoing out what that is. So we'll be able to see what it actually outputs when you hash a password. I have a spacer, and then I'm running that password that I just created, or that hash that I just created. I'm running it through the verify method to verify. Now, because I'm taking the password from up here and the hash we just created on the fly, I'm not actually pulling anything from the database. So this should always return true in this particular case, what I'm doing here, because I'm pulling them right from here. There's no way they would be different. Again, another spacer. Here, I'm going to print out the info, so you'll be able to see what the get info function does. And then down here, I'm doing a find cost, so we can actually see what it says my cost should be for my particular server. So this is something you can call on your server to see what your cost should be. If it says something other than 10, then that's when you can come over here to your class, to the constructor, and here you could put, let's say it says your cost should be 11. Well, then you can do cost and 11 like that. And now that's the cost that it will use. And if you had been using 10, when people log in, this particular class will automatically update them to use the new 11 cost, and it'll rehash their password. All right, so again, this is what we're going to take a look at. So let's go ahead and jump over and take a look at all of this. So let's just go ahead and refresh this. So you can see that this is the hash, and this is actually more than the hash. I'll explain that in a second, but you need this whole thing stored in the database. It has some information in here that PHP uses. This is the verify hash. So 1 means true, so it's saying that the password that was submitted and the hash that was created match, which of course they should. This is the options array. So this is telling us the algorithm we're using. This is essentially an identifier for what algorithm we want to use. This is 1, which is the default. The algorithm name is Bcrypt. So that's what we're using because that's the default currently for PHP. Here we have our options that have been set. So the cost is 10. Now we didn't set that manually, but that's what it pulls from this this little chunk here, this string here, and knows that it's the cost. And then down here is our test for finding our cost, and it says we should use a cost of 10, and that's what the default is. So we could just go ahead and use the default. All right. Now with the hash, as I mentioned, this is more than just the actual hash. So if we come over here to PHP, it actually tells us what it is. So these first 4 characters here tell us what algorithm it's using. Here we have our algorithm options. So this happens to be our cost. You can see it says 10 right here because that's the default. The next chunk is the salt. So this is how PHP knows what salt was used for a particular hash. And then this is the actual hashed password. So again, we store this whole thing inside of the database. And when we send this to verify password knows how to break this down and say, okay, this is the algorithm used. These were the options that were set. This was the salt that was used. This is the hashed password. And so it can rehash the plain text password according to the same settings and check it against this hash password and return true or false. So you can see it's doing a lot of stuff for you. And so that's why you want to use it as much. Well, that's why you want to use it always, because it's not only more secure, but it's doing all of the hard work for you so you don't have to do it. All right. Last piece then is, this is, as I mentioned, available in PHP 5.5 and above. Now, it may be the case that your server's not running PHP 5.5. It may be running something like PHP 5.3. So, first and foremost, if you can update your PHP without causing a bunch of issues elsewhere, then you should. Or even if it is causing issues, maybe work through those to get it updated. But that's not always feasible. So if you're want to start using this right away and you're on, say, 5.3, there is a class available on GitHub called password compat, and it will actually, it's kind of like a polyfill in a sense. It'll actually fill in the functionality. So this is, you can see it says here, it's intended to provide forward compatibility with the password functions that ship with PHP 5.5. Now it requires 5.3.7 or greater, or a version that has the $2y fix backported into it. So like Red Hat provides a version like that. You'll notice it says that Debian 5.3.3 is not supported. So it tells you essentially what you need here. But if you have 5.3.7 or greater, then you can use this password compatibility class, and it'll actually fill in all of those functions for you. And then when your server is updated to 5.5, this actually checks for that, and will actually stop using this class once your server is updated to 5.5. So it's an easy way for you to get the backward compatibility that you need to start using these right away, even if you're on 5.3. So you can see, to use it, all you have to do is require the password.php file that's in the lib folder from the download here. So if we go into the lib folder, you'll see password.php. This is what you need, and you just include that then into the class here that we have here, or whatever class you end up using, and then you can start using all of these functions in here. All right, so I can tell you, having done some password stuff before this was available, that this is a heck of a lot easier and going to be a lot more secure. There was, even though I had done a ton of research on it, there still was just a ton of gray area. And frankly, as a developer, you know, there's so many rabbit holes that you can go down. You end up having to pick and choose. And you know, to be honest, a lot of the clients that you work with, being a password hashing master isn't necessarily the thing that's going to be so attractive that they hire you. So this makes it nice and easy so that you don't necessarily have to be a password hashing master, and you can use these functions effectively and hash things appropriately and be secure, and now be future proof and rely on PHP to do all the hard work for you, do all the updating for you. So definitely way easier. You don't even have to store salts anywhere. which is nice. PHP creates the salt for you, which is just a way, it's way easier doing it this way and then way more secure. All right, so that is password hashing in PHP. Now, if you want to get access to this source code, then the way to do that is to head on over to johnmorrisonline.com/resources, or if you're on my website, you can simply click the resources tab right up here, and that will take you to my web developer resources page. Now, I have all kinds of web developer resources on here, from classes to the different tools that I use. But if you scroll down to the bottom here, then you'll see a section called code snippets, and you'll see PHP code snippets, WordPress code snippets, and Genesis code snippets. So you can go ahead and click on through to the code snippets that apply for the video you're watching, and you'll be able to get access to that code snippet. Now, if we click here, for example, on PHP code snippets, then we will be taken to that page, and you'll see all of the different code snippets here, and you can click through and you'll get the video, you'll get the description, and you'll get the code snippet as well. So again, head on over to johnmorrisonline.com/resources, head on down to the code snippet section to get access to the snippet that you're after. Of course, while you're here, you might as well look around and see some of the other developer tools and courses that I have available here that are going to help you down your path of becoming a web developer. And since I'm constantly adding to this page, then you might as well bookmark this page and check back often so you can see all of the things that I've added and get access to all of the tools and snippets and courses and things that I'm using throughout my career. All right, that'll do it for this episode. Thanks for watching, and I'll talk to you later.